Reconstructing the Indoor Climate of Historic Buildings. My name is Wolfgang Stumpf from Danube University Krems in Austria. The usage of a room, as you know, is influenced by its geometry, openings, alignment, views, light, materials, colors, etc. And this is my thesis, and the thermal comfort in the room. Because if a room offers comfortable conditions, it will be used accordingly. So the questions in this work are, what was a room, a building in its earlier or original state possibly used for? How can we reconstruct the indoor climate of a room that no longer exists in its original state? Which parameters are essentials to reconstruct the indoor climate of a historic building? With this method, described below, the assumed use of a space can be verified. To develop this method, I investigated 3 totally different buildings in different climate zones and different uses. First, it's the Danube University in Krems. That's where I'm sitting now. The second is a Museum Effendi, an art gallery in Indonesia. And the third test object was the Al-Nawar House in Jeddah, Saudi Arabia. The method for the reconstruction consists of 8 steps, which are described as followed. The first step is that we need a building survey, a regular building survey. The second, we do an airflow analysis of the airstream through the building. So we can calculate and measure or also simulate or assume the air change per hour. How often is the air volume in a room exchanged per hour? Then we have to organize and get the outdoor climate data with temperature, humidity, and wind speed. This comes from a database or also from monitoring on site. We need the building physical characteristics of the construction and surface materials in the room. And we have to calculate the indoor temperature and humidity, described here in equation 1 with the temperature, indoor air temperatures over time, and the change of indoor humidity over time. With these numbers, information, and data, we can assess the thermal comfort according to European standards. Here is the indoor climate, the air temperature, surface temperatures, air humidity, air velocity, everything calculated. And we also know from the building survey who is using the room or who was using the room, what was it wearing and doing. So clothing, insulation, and metabolic rate, this comes from the values come from the European standards, there are tables. We can calculate the percentage of persons in the room dissatisfied. And so we can describe the thermal comfort as comfortable, very comfortable, or not so comfortable. With all these results, we can compare the results with the assumed purpose of room use. I will show you on the example of 3 buildings how I developed this method. I started at Danube University Krems, where I monitored the indoor temperature of one room. Here is the monitored temperature profile, which overlaps the calculate indoor temperature. So the formula and the method works with the temperature. When I was in Indonesia in 2019, I investigated this art gallery. I monitored and measured the surface temperatures, air temperature, humidity, indoors and outdoors, air velocity, wind speed. Here is the monitored temperature profile, and the dotted line indicates the calculated indoor temperature. Average during opening hours is 31 degrees Celsius, and the humidity fits more perfect. So the monitored and calculated relative humidity in the room overlap very well. With the assessment of thermal comfort in the room in the situation 2019 brings a result that 64% of persons, of visitors in this room are dissatisfied with the thermal comfort. When I apply this method, the calculations and the investigations to the original state in the year 1974, as described by the artist Affandi, then I come to another result. Affandi wanted a permanent natural ventilated room here. When I took this in account, I got this profile, temperature profile and humidity profile. So the average temperature is 28 degrees Celsius during opening times for the visitors and 65% relative humidity. In the assessment, we see that there was a quite comfortable indoor climate, not perfect, but it was okay. 12% of the persons, of the visitors in the room were dissatisfied with the thermal climate. And when on top of this wall, the small openings were still existing, we had a permanent airflow. Here is the airflow in the room and a lower temperature, but a little bit higher humidity. So he was right. The original state was working. He had his idea, his concept was right. Only the direction of airflow was wrong. In a third test object, I also proved this method. I reconstructed the indoor climate, the temperature, air velocity, and relative humidity in a room of an already abandoned residential building in Saudi Arabia, in Jeddah. A group of colleagues from Technical University Vienna did a building survey and historical research and material investigations here in the year 2012. So I got this information from my colleagues in the Technical University Vienna. I've never been there. I don't know this room in its realistic state. And so I reconstructed the situation when the building was still inhabited. The result was that between 9 o'clock in the morning and 2 o'clock in the afternoon, the thermal comfort was given. Here we are in the green zone. Only 8% of persons in this room were dissatisfied. This is what we see here with the owner of the building, Sami Nawar. He owns the Al Nawar house and he grew up in this building. Here, this is a scene when he invited the colleagues from Technical University Vienna and described the way of living and using this house. And as you see, he sits in the shaded corner in the airflow between the cross ventilation from these two windows. He's relaxed, drinking warm tea. And for the situation of living, talking, inviting guests, the usage of the room is perfect. And he knew this place and way of use. So that's what I proved with my method. It is comfortable. Yes, he is right. And also the artist Affandi, here shown on a self-portrait, sitting on a bench in the porch of his house and thinking about new paintings or how he wants to design his own gallery some of these days. And he was sensitized. He felt the cool breeze from the garden, from the trees. He knew what to do at which time. And this is how he found the design for his art gallery. So the result of this work is the method works. Sami Nawar and Affandi were right. It is comfortable. We can reconstruct the situation as they described it. As an outlook for future work, I can say that for reconstructing the indoor climate, it is necessary to supplement and combine a conventional building survey with building physics methods. Thank you and goodbye.